All right, I'm glad somebody finally asked me for another example from those geometric mean diagrams, or little tattoo diagram problems from the problem set today. I know that I did the videos for 23 and 25, but oftentimes that's not enough because these problems are tricky, right? They started with the B-level problems, supposed to be kind of tough here. So I haven't done this problem yet this year, so this might even take me some time to figure out. Kind of the thing maybe you can look at here is that you know the hypotenuse. That's helpful. Okay, you know this is the hypotenuse. Maybe you can label this one in here, right? This is length y, so this is going to be 15 minus y, because again, by the segment addition postulate, this plus this must equal that. So if this is y plus 15 minus y, that's going to make the segment addition postulate true, right? This part plus that part equals this part, and y plus 15 is just y plus 15, but we're subtracting y. Those cancel out, and 15 equals 15. So it checks out from the segment addition postulate. Okay, so we'll make that one this, and because we have the hypotenuse, we don't know what this is, we don't know what this is, but we don't know what that leg is. We don't know what that altitude is. This here, 9 is the geometric mean of two of the other segments on this one here. So that's helpful here. Z, we don't know what Z is. That's going to be the geometric mean of that segment and that segment. That doesn't really help us, right? Because this is Y, that's Y. This is Z, that's more than one variable. X is the geometric mean of Y and 15. And that doesn't really help us because we'd have X in an equation and Y and 15 in an equation. So we'd have more than one variable. So what I'm looking at doing first here is just 9, because 9 is the geometric mean of the segment of the hypotenuse that's adjacent to the 9 length, right? Remember, this is an altitude that created segments of the hypotenuse. So 9, it's the geometric mean of this segment of the hypotenuse it's adjacent to, and the whole hypotenuse here. So thus, I set up my equation with 9 being my geometric mean of 15 minus y and 15. Now, I have an equation. I only have one variable in it. I can solve for that variable. So what I'm going to do, I'm going to cross multiply, right? Cross multiply. 9 times 9 is 81. And 15 times 15, mental math, 225. Okay, you can go with the calculator, but whatever helps you go fastest, right? Don't ask you guys to memorize your multiplication tables, although I hope you know them, because multiplication is kind of like the most important thing, I'd say, in high school math. So, and earlier math too. But anyways, we got this here. So now I got 15y. I'm going to move the negative 15y. I'm going to add 15y to both sides. So I'm going to put 15y over here. Subtract 81 from this 225, and that mental math is what? So 144. Perfect. I like that. Well, I like 144 when it has a 12 there. There's a 15 there. Ooh, ugly. Okay, so what I'm going to do to both sides, I'm going to divide both sides by 15 to get my answer. Does 15 go into 144? No, it doesn't, but it goes into 150. It goes into 130. How many times does it go into 130? So it goes in 15 times, so it'll be 9 and some change here. So let's see here. 15s cancel out. Y is going to equal 9. So 9 would bring us to 135, and then it would be 9 more on top of that. So 9 and 9/15, I can simplify 9 over 15, and that would be what, 3/5? Yeah, 9 and 3/5. Okay, you could have left it as a mixed number or starting improper fraction. That's fine with me, but I think the answer key has this one here. All right, so I got this one here. Hopefully I'm right about that. I'll maybe do some mental math to figure out if it makes sense. My answer makes sense here, and I actually don't think it makes sense. I think I made a mistake here, because this is, oh wait, I solved for y. Oh wait, okay, cool. Actually, you know what? I don't think I made a mistake here. These are tricky problems here because y is over here. So I was dealing with 15 minus y. So we'll maybe fill that in a second, just to show you that I kind of got this one right, because y is going to be over here. We solved for y. Y is over here. That's 9 3/5. That means that this segment of the hypotenuse here would be 15 minus, right, minus 9 3/5. That would be 5 2/5. And that makes sense to me. Okay, that makes sense to me. Why does that make sense to me? Because 9 is the geometric mean of 5 2/5 and 15. Okay, and if you're a mean of something, right? Mean. Remember, there's an arithmetic mean, there's geometric mean. Mean kind of means some sort of a middle value of some kind. It depends how you define it. This is sort of a proportional mini value. This segment to that segment is the same thing as that segment to this other segment over here, right? So geometric mean. This is certainly a mean, right? Because this is 9 is in between 15 and 5 2/5. It's kind of, I kind of feel like it's maintaining that proportionality, right? If this were 5, that's 10, that's 15. Right, 10 is definitely the geometric mean of, wait, no, it's not geometric mean of, what am I talking about here? 10 is the geometric mean of 5, 10, and 5 and 20, but not 5 and 15. But anyways, this feels right to me, right? Because these numbers they all make sense. Now this is 9 3/5 for the y here. Check it out. So now I can get this. I can get either one. So I can get either of the other variables here. Check it out here. Z is the geometric mean of this and that. Cool. That's the only variable that would be in it. X is the geometric mean of 15 and 9 3/5. Because I have that here, maybe my mind is kind of going with it, with the leg of the large triangle is the geometric mean of the segment of the hypotenuse it's adjacent to and the hypotenuse itself. So maybe I'll go ahead and solve for that one right away here. So I got this, X and X right here. And then I got 15 for the hypotenuse. I usually get a little to small, bigger, and then bigger to really big. That's usually how I have it set up here. So I'm gonna put the bigger guy down here. Doesn't really matter how you set it up though. You still get the right answer if you get it done here. Okay, so this is 9 3/5. Ooh, messy. Cross multiply. Ooh, this is a messy problem set here. So X is a geometric mean. We're gonna have to take a square root at some point. Ugh, that's ugly. Especially if we haven't practiced simplifying radicals yet. That'll be your homework tomorrow. X times X is X squared. 15 times 9. Well, we just did that like earlier, right? Didn't we do that? 15 times 9 would be 135. Oh, it would just be this over here, right? So it would be 144, right? Because that's how we originally got the 9 3/5. Okay, so 15 times 9 3/5 is 144, and that's why they chose 144 for this. Check this out here, because 144 is a perfect square, right? Is a perfect square. 10 times 10 is 100. 11 times 11, right? That would just be 100 plus 11, which would be 111, and then plus 100 plus another 10. So you've done 11 times is 110. Then add 11 to that to get 11 times 11. Anyways, that's 121 would be 11 times 11. And then 12 times 12 is actually 144. So the square root, if you did it in a calculator, if you're not really good at your squared numbers yet, you'll get good at them because you would do a lot of squaring, a lot of square roots. Square root of 144 would equal 12. So I got 12 here for X. That's going to make sense to me because, again, 9 3/5 and 15, it kind of makes sense proportionally, right? 9 to 12 would mean a 3 to 4 ratio. And 12 to 15 would be in a 4 to 5 ratio. Yeah. So this is sort of kind of in between here, right? It's in order to maintain that common ratio here. 9 3/5 to 12 is in a 4 to 5 ratio, right? In a 4 to 5 ratio, you could prove it. I'm not going to spend time doing it right now, but that's actually in a 4 to 5 ratio, and then 4 to 5 ratio from 12 to 15, right? That's where I got that 4 to 5 from. Anyways, doesn't really matter. I just sort of am sort of rambling and trying to form a little bit more connections for you in case you're not seeing that, and just maybe some other things we can talk about here. Z is the geometric mean. So this is the easier one, right? I think this is the one that people don't forget and get here. Well, that altitude's definitely, so here, it's all in the big triangle, right? Well, not really on the big triangle. It's the altitude of the big triangle and then the two legs, right? Those are the things you have to be worried about in terms of being the geometric means here. 9 is a geometric mean here. X is a geometric mean here. And finally, Z, the altitude. So it's all over here. All your geometric means in here. Anything that's going on the big hypotenuse, right? Big hypotenuse is sort of the extremes of your proportions, right? So then none of these. This isn't either of these. All three of these are not geometric means of any of the other shapes. It's the ones over here, right? So they are actually kind of like geographically located, right? Like these are geometric means here. These are things that are the extremes within these geometric mean statements. So we have Z is the geometric mean of the two segments of the hypotenuse that get formed when you draw that altitude in here. So I'm going to set it up. We got fractions galore on the homework tonight. And yeah, you might have to, I'd maybe change this to an improper fraction, cross multiply. So let's do that. I'll do that maybe in my head real quick here. Z squared is going to equal, okay, so 5 2/5. That's what, 27 over 5. And then this is 9 3/5. So that's going to be 48 over 5. Okay. Multiply them together. Remember, when you're multiplying fractions, it's numerator times numerator over denominator times denominator, right? A lot of people kind of freak out when they get to fractions, but that's something, right, you should practice over the years here, right? You're practicing again right now. Numerator to numerator, so we're going to do 27. Always have a calculator out in math class. A lot of times you're shocked about how many people don't actually have a calculator in class. It's one of the most surprising things to me as a math teacher is like, you want to make your life that hard and not actually have a calculator out here. So this is 1296 over 5. Okay, let's see. That feels like maybe that's a perfect square. Maybe we get lucky here. Take the square root. It is a perfect square. Check that out. 36 times 36 is 1296 here. So the next step of this to isolate Z would be to take the square root of both sides. Okay, so this is going to end up being Z equal to 1296. Take the square root. We get 36. So 36 over, well, this is square root of this guy. This is square root of the denominator, square over square root of 5. Now, what we're going to learn actually next class on Wednesday for homework, I already have some YouTube videos you watch here, is to how to address this situation. Because technically, well, we don't have to simplify the numerator. It was a perfect square. We got lucky there. The denominator is a square root, right? It's a square root right now. That's not good. Okay, reason why this is a square root of 5. That's something called an irrational number. If you do it on the calculator here, it'll kind of suggest that it's irrational. Okay, an irrational number is a non-repeating, non-terminating decimal. So it's kind of a special number. The square root of 5 got invented for this exact reason. Sometimes you have to find, you have an area of 5, you need to find what the dimensions are of a square. So we call that square root of 5. It turns out it doesn't have an exact decimal value. Ooh, that's kind of weird. So the fact that there's not an actual decimal value of square root of 5 means, how could you take that and divide that into a number, right? Square root of 5 is an irrational number. It's not going to terminate. It doesn't repeat. There's like not a pattern to it. So if you're trying to figure out how many times something that doesn't repeat or doesn't end goes into another number, then good luck with that. That doesn't actually work, right? You can kind of get an approximation, but it doesn't really work here. So anyways, the rule is, right, the math rule is you can't be dividing by an irrational number for that reason, right? It's not going to go cleanly into 36. So what you're going to learn in tomorrow's class is that you're going to take this, the way you actually it's called rationalize the denominator. I'll put this one here. And what that suggests is, it's not irrationalize the denominator, it says rationalize the denominator. And what that means is, we have an irrational number down here. We want to turn it to a rational number. So an irrational number is a non-repeating, non-terminating decimal. This will all get reviewed for an Algebra 2 too, so I'm going kind of quickly. But a rational number, okay, not irrational, a rational number is a terminating number. Or, right, terminating means ending, right? It's just going to end somewhere. Or a repeating number. Okay, so like 1/3 is like 0.33333 repeating. The number 5 is just the number 5, right? It terminates. The rest is 5.0 forever, right? The 0 is technically repeating, right? So anyways, we're going to change this from a square root of 5 to 5. This is how you do this, okay? So this is kind of a big part of Wednesday's homework, right? Your video lesson you'll have to do for that. And those are just YouTube videos I have here. This is technically, right, we're pretty close to the answer here for Z. What we're going to have to do is multiply both the numerator and denominator by square root of 5. Why am I allowed to do that? Well, this here is equal to what? Well, this is just like 2.26 approximately divided by 2.236 approximately, right? These are the same things, right? So what I'm doing is I'm taking this value, multiplying it by 1, okay? Multiply 1. And when you multiply something by 1, the actual quantity of it, what it represents, doesn't change, right? That's something called the identity property of multiplication, which, there's enough stuff in your books, enough rules in your books where we're just gonna have you accept that and can go with it. They don't write about the identity property here. So if I'm rationalizing this, I'm gonna do this. So what another thing you're gonna practice too on Wednesday's homework is that square root of 5 is down here, square root of 5 is down here. If you do the square root of 5 times the square root of 5, well, if I have this, and I square it, right? This is the square root of 5 in approximate decimal form. Oop, nope, I don't need to do that. I meant to square it. So, where did it go? There's square root of 5. If I square it, I get 5. So square root of 5 times square root of 5 undoes the whole square root, right? What number times itself equals 5? Well, the square root of 5. So square root of 5 times square root of 5 must be 5. And that's how we rationalize the denominator. We get a denominator of 5, okay, right? And that's a rational number. And there are other types of names for a number like the number 5. It's called a whole number. It's called an integer. There are other things like the rational number is the superset. We studied superset when we did quadrilaterals, right? Quadrilaterals is the superset, and then below that you have trapezoids and parallelograms and kites, right? And other non-convex quadrilaterals. And within those there are different subsets here. So 5 is a real number. It's a rational number because it's terminating or repeating. It's also an integer because it's either -5, -4, -3, -2, -1, 0. It's a number line number, or a shown number line number if you're scaling by ones. And it's a counting number. It's a whole number. It's a whole bunch of things. But when it comes down to it, you just need to get a rational number in the denominator. Something that actually divide into things here. So now we just need to simplify the top, because the top's got to change. If we're changing our bottom from square root of 5 to 5, then we need to have tacked on this square root of 5 to this 36. So this is 36 times by the square root of 5. Okay, this is kind of like a coefficient of this here. So anyways, there is z. Maybe I'll take a second to double check that that answer is correct in the textbook. And let's see what we got here. Boom. Let's see what we got. Patient. We're getting there here. I know it's late. All right, so yes, there we go. X is 12. Hey, they actually rounded here too. They didn't round, they used decimals. 9 3/5 is 9.6, that's what I got. And then this funky thing here, so I guess they don't expect you to do this. They don't expect you to write this as an approximate decimal value, but they're saying 7.2 for that. And 7.2 would make sense, right? 7.2 is between 5 2/5 and 9 3/5. So if I do this in my calculator, this is the exact radical answer in radical form, it's called. But if I'm going to get the approximate decimal answer, right, I would take, well, square root of 5. Right, remember the numerator is square root of 5 times by 36. 33. I'm hitting wrong buttons here. So 5. You thought you'd be done with this now by now. Times by, getting up with 5 there again. Okay, here we go. Square root of 5 times by, all right, good. 36 and divide by 5. I got the wrong answer. I got the wrong answer in this one here. Oh, I totally got the wrong answer. What did I do wrong in this one here? So I'm kind of glad I'm looking at this one. Man, it looks like it was so nice too. That's what I did wrong. Okay, so I didn't actually multiply this here. This is a mistake that I made. I didn't multiply my denominators. So this should have been 25. Okay. So then, yeah, this actually, we don't have to worry about rationalized denominator here. Check this out. I'm glad I gave you a little mini lesson here. So this is all stuff that's all fine and dandy, and I kind of showed that to you here. So it's a little bit of a heads up what you need tomorrow in Wednesday's class. But here I messed up. I multiplied my numerators correctly. That's a perfect square. 1296. Take the square root. That's 36. But I didn't multiply my denominators. Both denominators were 5, right? When I cross-multiplied, the common denominator is 5. So 5 times 5 is what you do when you're multiplying two fractions to one another to kind of come together. So I got to take the square root of that 25. Square root of 25 is 5. And that's where that 7.2 number comes from. Totally makes sense. 7 times 5, 35. Another 1/5 to that is 0.2. So 7.2 would be our answer, okay, for this here, and that would be Z. Got Z, okay? Thank you again for asking this question and going above and beyond, watching this video, trying to get into this one here. So on Thursday, you're going to have the even numbers in this section here. So I'm glad you asked. I'm glad you're learning this here. Thank you for asking. Take care. Bye.